Welcome to all of you. In this lecture, we will be realizing 74192 mod down counter using the multisim. So these two are the mod values that we will be realizing. The first one, design of down counter to count from 8 to 3. One more, design of down counter to count from 8 to 4. A detailed description of the design of these two has been provided in another video whose link will be given in the description box. So please go through that video. Later if you come back for this, then you will have a much better understanding of the design. Now this is the general realization, which are all the inputs and which are all the outputs, and this is the mode table. Now let us get into the design of the first one. So design a down counter to count from 8 to 3, that is n value will be equal to 6 using 74192. Let us get into the design part. So this is what the circuit we are supposed to get. So as we are working with the down count operation, the CPD will be connected to the clock and CPU will be connected to the VCC. So the initial value must be 8. Therefore, the preset has been initialized, that is D3 to D0 value is initialized to the value 8. So the count has to start from the 8 itself, right? So now as and when it reaches 3, after 3 it must come back to the 8. That's what the design we are supposed to make. For that, let us get into the truth table. So this is the value 8 we are starting with, and then it will be reaching to the value 3 in a down count operation, and by default procedure after 3 it has to go to value 2. That is what is represented in the red, but this value is not supposed to be appeared at the output. So as a part of the design, what we are going to do is the bits which are equal to 0, only those bits are considered for the design purpose. Remember, for down count operation, the bits which are 0, they are considered to design the mod counter. So in this case, Q0 is 0, Q2 is 0 and Q3 is 0. So Q0, Q2 as well as Q3 are being considered here in such a way that the combination of the logical gates must provide the output 0 only at this particular instant, not in any other case, only at this particular instant. So for that we have to identify a combination of gates. So in this particular case, the OR gate is going to work for us. And if you make a combination of any other previous case, output of this combination will remain as 1. Only in this particular case, the output of this combination is going to be 0, which is going to trigger the parallel load operation, which will load this value 8 to the output. Right? So as I told you before, a detailed video is available. You please go through that so that you can have a very clear understanding of how it is going to be done. Now let us get into the multisim procedure. Okay, so with respect to the multisim, so this for the 74192, the basic connections has already been done, and which are all the requirements, the clock, VCC, it has been taken, and this for the truth table of the down counter. Now we need to configure this so that it can perform this down counting operation, right? So which are all the connections we have to make? So we have to take two OR gates to which the inputs like this, that is the Q0, the Q2 as well as Q3 has to be connected, and its output has to be given to the parallel load operation. That's the first procedure. Let us make that. So we need to select OR gate. So this for the 7432 OR gate. So select it. So I'm going to take the first one. So place it over here, and then take the next one. So place it over here. So that is enough. So I need to rotate this, use Control R to rotate this also. Let us take Control R to rotate. So let me make like this. So for this one, I'll be connecting the Q0 as well as Q0 as well as Q2. So see, this is Q0 and then this is Q2, right, and then Q3 will be connecting to the second one, and output of this OR gate I will be connecting to this one, and then final output of this combination I will be connecting to the load signal, right. Then the clock has to be connected to the down count, and the up count that has to be connected to the VCC. Right. So now from where the value has to get started, it has to start from 8. Therefore, so this one will be connected here, and all other remaining 3 must be connected to the ground. See, all connections are being done. So during the first cycle, I'm not exactly going to start with this value. So as I told you before, so from the second cycle and onwards, so this will be connected. So because every time I need not to make the changes to the load, I'll be making this as a default circuit. So let us just go through the down count operation and let us see how it is going to work out. So I'll be running this. 8, then 7, 6, 5, 3, right? So I'm not getting the value 2, as you can observe over here. After 3, it will be shifting to 8. 3, then shifted to 8. Right? So this was the truth table. So now, as per the truth table, now it is working fine. Now let us get into the design of one more down counter. So that is design a down counter to count from 8 to 4. That is n value is equal to 5 using 74192. Now this is what the circuit we are going to have, and it has to count from 8 to 4. So value 8, and then
So what are all the
7,
connections that are needed?
6,
So let us just
5,
make an
4.
identification of that.
I'm not supposed to get
So
the value 3.
Connections
Instead, I
together,
must get back to the value
Q2
8.
and Q3.
That's what the
Those
procedure.
2 bits are 0.
So let us get
they
into
must
the
be passed through
procedure
the
over
OR
here.
gate and
So I'm
must
not
be
going to
connected
make
to
any
the
explanation which
load
one we
signal.
have to connect. As I told you before,
Right?
the
So
values in this particular case, the bits which are having the value 0,
okay.
those
So now connect
bits must be connected to the OR
Q3
gate.
bit.
Output of the OR gate must be connected to
Then
the parallel load
connect to
operation.
Q2 bit.
So in this particular
This
case,
must be
Q3 and Q2 are
connected
equal to 0 in this particular
load signal.
value. So those two bits are preferred, and they are connected through the OR gate to the parallel load operation. Now let us get into the multisim procedure for this one. So all other things will remain the same because the initial value again here also it is 8. So it has already configured to the value 8, and the clock down it has already been given. Now after first cycle, so everything is going to start from this and going to end with this value. So let us make a cross check of that one. So I'll be running this one. 8, 7, 6, right?
So it is not entering to this particular value. Right? So as you can observe, after this value, it will be directly shifting to 8. So there is a flash like appearance shifting to this value and then moving back to this value. In here it's a small delay. Right? Okay, so thanks for joining.